This is the online class organized by the State Council of Science, Technology and Environment. I welcome you all viewers and especially my dear students. The topic for today is Introduction to Trigonometry. Let us begin. Trigonometry is a branch of mathematics which deal with the measurement of sides and angles of a triangle, where that triangle is known as a right angle triangle. Okay, now let us come to angles. What are angles? Angles. If I draw a line starting from this point and it goes indefinitely in one direction, this is called a ray. If I draw another ray, suppose this one, then the measure between these two rays is called an angle. Let us denote this angle by theta. Okay, you can see here that these two rays originate from the same point. This is called the vertex. Let us denote this vertex by O. Alright, let us denote this one ray by OX and the other ray by OB. Okay, now let us go to a few basic types of angles. One is acute angle. Number 2 is obtuse angle. And number 3 is right angle. Alright, what are acute angles? Acute angles are angles which are less than 90 degrees. Suppose this one. This is an acute angle. Alright, next, obtuse angle. Obtuse angle is an angle more than 90 degree but less than 180 degree. Suppose this one. This is an obtuse angle. Alright, next, right angle. Right angle is an angle of exactly 90 degree. Let's draw. This is a right angle. Okay, now let's go to another topic. The next topic is trigonometric ratios. What are trigonometric ratios? Trigonometric ratios are ratios of the sides of a right triangle with respect to its acute angles. Alright, there are 6 trigonometric ratios. They are sine, cosine, tangent, cotangent, secant and cosecant. These are referred to as ratios since they can express in terms of sides of a right angle triangle for a specific angle theta. Alright, now let us consider an acute angle. This one. Okay, so this is an acute angle. Alright, if I take any point on OY, suppose here this is the point, and I draw a line from this point perpendicular to OX. Let us denote these 2 points by A and B. If you look at this figure, you will observe that OAB is a right angle triangle. Right. OAB is a right angle triangle. Now, sine of theta is given by, where this OA is the hypotenuse. B is the base. And AB is the perpendicular. Right, now sine theta is given by perpendicular by hypotenuse, which is AB by OA. AB by OA. Alright, cos theta is given by base by hypotenuse, which is OB by OA. And tan theta is given by perpendicular by base, which is equal to AB by OB. Alright, so cosec theta, you see here that sine theta is perpendicular by hypotenuse. Now cosec theta is given by hypotenuse by perpendicular, which is equal to OA by AB. Now cos theta is based by hypotenuse. Sec theta is given by hypotenuse by base, which is equal to OA by OB. Alright. Tan theta is given by perpendicular by base. So cot theta is given by base by perpendicular, which is equal to OB by AB. Alright. You see these three trigonometric ratios. We can also remember these three trigonometric ratios by one sentence, which says some people have a curly black hair that turns permanently black. Alright, and the other three trigonometric ratios is just the reciprocal of the other. Because sec is just the reciprocal of sine, sec theta is just the reciprocal of cos, and cot theta is just the reciprocal of tan theta. You can see from here, cosec theta is equal to hypotenuse by base. Alright, so you can also write 1 by perpendicular by hypotenuse. Alright, so 1 by perpendicular by hypotenuse is sine theta. So you can write 1 by sine theta. Okay, now cosec theta is equal to 1 by sine theta. Next, sec theta can also be written as 1 by base by hypotenuse. Base by hypotenuse is cos, so you write here cos theta. Okay, so sec theta is equal to 1 by cos theta. Okay, next, cot theta. Cot theta can also be written as 1 by base by perpendicular, right, which is equal to 1 by tan theta. Therefore, cot theta is equal to 1 by tan theta. Alright, now you see tan theta is equal to perpendicular by base. Alright, if I divide both numerator and denominator by hypotenuse, b by h and b by h. Alright, so perpendicular by hypotenuse is sine theta. So it is sine theta. And base by hypotenuse is cos theta. So you write here cos theta. Okay, next, cot theta is base by perpendicular. Again, if I divide both numerator and denominator by the hypotenuse, right, base by hypotenuse is cos theta and perpendicular by hypotenuse is sine theta. So we got this formula. Let us do some exercise. Okay, the question says in triangle ABC, right angle at B. Alright, if AB is equal to 5, BC is equal to 12 and AC is equal to 30, find all the 6 trigonometric ratios of angle A. Alright. First, let us draw a figure. Alright, in triangle ABC, right angle at B. Let us draw first a right angle triangle. By questions it says that right angle at B. So B will be here. Right. Now we have, if AB is equal to 5, BC is equal to 12, AC is equal to 30. We know that the hypotenuse is the longest side. Right. So from here AC is 30. Right. So AC is the hypotenuse. Okay, so it's 13. AB is 5 and BC is 12. Okay, now we have to find all the six trigonometric ratios of angle A. Okay, now sine of A is given by perpendicular by hypotenuse, which is 12 by 30. Cos of theta is base by hypotenuse 5 by 30. Tan of A is given by perpendicular by base, which is 12 by 5. Right. Cosec theta, cosec of A, since here the question says that we have to find the trigonometric ratios of angle A. So it should be, instead of theta, it should be A. Okay? Now cosec of A is 13 by 12. Alright? Sec of A is 13 by 5. And cot of A is 5 by 12. So this is the answer. Okay? The next question is, okay, if cosec theta is equal to 2, find the value of cot theta plus sin theta by 1 plus cos theta. Given cosec theta is equal to 2, but we know that cosec theta is equal to hypotenuse by perpendicular. Alright, so here 2 we can also write 2 by 1. Okay, so here the hypotenuse is 2 and perpendicular is 1. Let us draw a figure. Let us draw a right angle triangle. Okay, the hypotenuse is 2 and the perpendicular is 1. So first let us find the base. Let us name this right angle triangle by A, B and C. So first let us first find AB. Okay? Now to find the base we use that Pythagoras theorem. Okay? By Pythagoras theorem, AC square is equal to AB square plus BC square. Alright, now AC is 2, so 2 square is equal to AB, we have to find AB square plus BC square. BC square is 1 square. Okay, now 2 square is 4 and you bring this one to the other side, you will get minus 1 is equal to AB square. Alright, now AB square is equal to 3. Which imply AB is equal to root 3. Okay, we have found out that the base is equal to root 3. Alright, next let us find the value of cot theta, sin theta and cos theta. Okay, cot theta is given by base by root 3 by perpendicular, which is 1. Sin theta is given by perpendicular by hypotenuse, which is 1 by 2. Alright, and cos theta is given by base by hypotenuse, which is root 3 by 2. Okay, we have got all these three, then we'll put it here. Okay, now cot theta plus sin theta by 1 plus cos theta is equal to, cot theta is root 3 by 1, just simply write root 3 plus sin theta is 1 by 2 and 1 plus cos theta here is root 3 by 2. Okay, now let's write root 3 plus 1 by 2. Here in the denominator, let's take LCM. The LCM here is 2. So here will be 2 plus root 3. Okay? Now 2 cancel. We will get root 3 plus 1 by 2 plus root 3. Okay? Again, let us take LCM here. 2 plus root 3. Here we will get root 3 into 2 plus root 3 plus 1. Okay, let us multiply root 3. Root 3 into 2 will be 2 root 3 plus root 3 into root 3 is 3 plus 1 by 2 plus root 3. Okay, then 2 root 3 plus 3 plus 1 is 4 by 2 plus root 3. Again, in the numerator, you can take common 2. If you take common 2, then you will be left out root 3 plus 2. In the denominator, you can also write root 3 plus 2. 2 plus root 3 is same thing, root 3 plus 2. Okay? Now, root 3 plus 2 and root 3 plus 2 get cancelled, then you will left out with 2. Okay, so this is the answer. So that's all for today. Thank you.